Hello class, today we are taking a look at finding the equation of a relation that is given to us in an ordered pair. Now instructions tell us to create the equation for each relation and to check that at least two ordered pairs satisfy that equation. There's a few things that we know about the relation shown in an table of values. We know that in grade 7 all of our relations fit the word pattern that we are starting with some number and then adding some other number each time we increase our pattern. And so if we take a look at these values, we know that when our input or x is 0, that is what we consider our start. So in this case, we are starting with positive 3. Now we can look at the pattern in the changes between the rows to see what we're adding each time. So we can see that x is going up by 1 in this table of values, while y is going up by 2. And so we can say that every time we increase x by 1, we're adding 2 each time we do that. Now those two values fit into our equation as well. And our equation is always in the format that y will be calculated by doing some sort of coefficient in front of x, and then adding or subtracting some constant after x. And we can take the values from our word problem and put them into those spots. Now the coefficient will be the change that you are doing each time. So in this case, since we are adding 2 each time, our equation is going to be y equals 2x. And then what we're starting with, our constant, will be the constant after the x. So in this case, we'll have the equation y equals 2x plus 3. Now, of course, that is our finished equation. We don't really need those boxes around our 2, our x, and our 3. So really, we would normally just write this as y equals 2x and then add 3. Okay, now if that is the true equation of this relation, then that means that when we put in our y's and our x's from our table of values, the left side of the equation should be equal to the right side of the equation. So let's color code those y's and x's like we did in our notes, and let's use blue for y, and let's use red for x. And then we can check our equation using these points here. So our first point says that when x is 1, the equation should calculate that y is 5. So let's check that that's the case. Our equation said that y should be equal to 2 times our x, and then adding 3. So let's put in our numbers. We said that y should be 5, and that would be created when x in the equation is 1. We're going to check that our left side is equal to the right side. So our question is 5 equal to 2 plus 3? And of course, yes, it is. The left side is equal to the right side. And we know that our equation worked for that point there. Let's check our next point. So we'll do the same process. The next point says that when x in the equation is 3, the y should be 9. So again, I'll just rewrite down our equation here, that we have our y should be equal to our 2 times our x plus our 3. That's what we think our equation is. And so let's put in that when y is 9, that should be created by 2 times an x of 3, and then adding 3. So let's check that each side of this equation is actually equal. So is 9 equal to 6 plus 3? Yes, it is. So of course the left side does equal the right side. And we know that our equation worked for both of those points from the table of values. Of course, the first point being from this line of the table of values, and the second point being from this line of the table of values. Now, it really doesn't matter what points you choose in your table of values to check your equation. If your equation does work for 2 points in your table of values, then it is going to work for all the points in your table of values, as long as you've really confident that you haven't messed up the calculations for those 2 points. Let's take a look at our next one here. So for our starting value, we want to start with the y value when x is 0. So we see that when x is 0, we're starting with minus 2 as our output, and we're adding what each time. So be careful with your integers. When x goes up by 1, y is going up by 3. And we can see that an x of up by 1 also gives us a y up by 3 in the next row as well. So we're adding 3 each time in this particular equation. So let's write our equation. We know we're going to have y equals something times x, and then plus or minus something. We know that what we are starting with will be our constant after our x, and what we're changing by each time will be what we are multiplying x by, or our coefficient. So our equation for this table of values would be y equals 3x subtract 2. So in this case, they haven't told us which values to check or which ordered pairs to check. So I'm just going to choose 2 of them. I'm going to check that when I have an x value of 2, I should have a y value of 4. And I'm going to check that when I have a an x value of 4, I should get a y value of 10. So let's put those into our equation. Again, we think our equation here is that the y should be made by doing 3 times the x and then subtracting 2. That's the equation that we think for this table of values. So let's plug in our numbers. So this point says that a y of 4 should be equal to 3 times an x of 2 and then subtracting 2. So 4 should be equal to 6 minus 2. And that is a true statement. For our next point, it says that a y of 10 should be equal to 3 times an x of 4, and then subtract 2. So is 10 equal to 12 minus 2? Yes, it is. And so we know that our equation works for that point as well. Let's take a look at our next one here. This one is the first one that has a few tricks in it. So again, we want to think about what are we starting with and what are we adding. So remember, when we say starting with, it means what's the output when x is 0. And the first trick in this table of values is that the first row is not having x is 0. It has x is minus 2. So we want to look through our table of values and find the first row where x is 0. And we know that we're starting then with the y value of positive 9. Now let's look at the changes in our table. So we know that when we go up by 2 in our x, our y is going up by 4. So you might be tempted to say you're adding 4 each time. And I mean, you are adding 4, but it's not each time, it's each 2 times. X is changing by 2 this time, not 1. So we don't want to say add 4 each time because that's every 2 x's, not every 1x. So what are we doing each time? Well, we know that we are going up by 4 in y every time we go up by 2 in x. So we want to figure out, well, how much am I going up by to go up by 1 in x? And obviously 4 divided by 2 gives me 2. So I'm actually adding 2 every time my x goes up by 1. And you can confirm that by thinking about, well, if I add a row, let's say I add this row here, between 0 and 2, I'd have x is 1. How would I do equal hops to get to my y value? Well, I know that I go up by 1 and then up by 1 again. And over here, to have a total of up by 4, I'd have to go up by 2 and then up by another 2. And that would give me 11 in the middle. So notice that every time x goes up by 1, the y would have to go up by 2. So we are adding 2 each time. So let's write the equation of the relation. We know we're going to have y equals some number times x and then plus or minus some number. We know what we're adding each time is going to be our coefficients. So in this case, we are adding 2 each time. And then what we're starting with is our constant. So in this case, our constant is going to be positive or plus 9. And that's our finished equation for this relation. So let's go ahead and check some points. I'm going to choose at random to check the point that x is 4 and y is 17. And I'm going to choose for my second point that x is 6 would create y of 21. So let's do those points. So an x of 4 would create a y of 17. And the second point, an x of 6, should create a y of 21. And that's my green one. and this is my yellow. I guess I missed that up here. That one's yellow, and that one is green. Okay, so let's use our equation. Our equation says that our y should be created by 2 times whatever x is, and then adding 9. So let's plug in that a y value of 17 should be created by doing 2 times an x value of 4, and then adding 9. So is 17 equal to 8 plus 9? Yes, it is. And so we know that our equation worked for that point. In the second point, we again know that our equation that we think is correct is y equals 2 times whatever x is, and then adding 9. So the second point says a y value of 21 should be created by 2 times an x value of 6, and then adding 9. So we want to check, is 21 equal to 12 plus 9? Yes, it is. And so we know that that point worked in our equation as well. Now again, you can choose any 2 points if they don't tell you which ones to use. So I chose the last 2 in this table of values, but you could have chosen any 2 points in the table of values and found that correct, that your equation did work. Now let's say if you made a mistake. Maybe you made the mistake and you thought it was 9x plus 2. You'd find that your equation doesn't work. So if we put in a y of 17 and an x value of 4, obviously 17 is not equal to 36 plus 2. And so that would tell me that this equation must have been wrong, and therefore that I should revisit my work to double check and notice, oh, oops, I mixed up the coefficient and the constant. Okay. All right, so the ones on the front are pretty basic. The first 2 are pretty much as easy as it gets. And the second one there, or the third one there, is a little bit harder because we do have a different change between our y values and our x values, and also our 0 row is not at the top. Going on to the back with question D, we do need to use our pattern a little bit here. And the issue with our pattern is we can't see where x is 0. We only have x's 1, 2, and 3. So let's use our pattern to see if we can figure out what we were starting at. For the ones I do have, I notice that I have a change where x is going up by 1 and y is going up by 3. So that means if I want to go back or down by 1 to get to x is 0, I should instead go down by 3 to get a y value of 4 at the start. Okay, so I can say that I'm going to start with my 4, and that is positive 4, I should say, and we have to add 3 each time x goes up by 1. So for my relation, that's going to be my y equals, my change each time is going to be my coefficient, then my x, and then what I'm starting with is my constant, so that will be my plus 4. Let's go ahead and check 2 points. I'm going to check the last 2 points again. So I'll check the point that when x is 2, y should be 10, and I'll check the point that when x is 3, y should be 13. So let's plug those into my equation. My equation says y should be equal to 3x plus 4. That tells me a y value of 10 should be created by 3 times an x value of 2, and then adding 4. So is 10 equal to 6 plus 4? Yes, it is, and I know that my equation worked for that point. Let's also check this point here. So again, the equation that I think is correct is that y is equal to 3x plus 4. This point should mean that a y value of 13 should be created by 3 times an x value of 3, and then adding 4. 3 times 3 is 9, and 9 plus 4 is 13, so that point worked in my equation as well. So I know that my relation y equals 3x plus 4 is correct for this table of values. In question E, again, we need to do some work here to figure out our starting value. We're also going to need to do some work dealing with our changes. So if we look at the current changes we have in our table, our x's are going up by 2 when our y's go up by 6. And so we want to figure out what the change is for a 1 change in x. And so I know that if I broke this up and I instead went up by just 1 and then 1 again, that would be half of a jump. And so if I want to make a total of 6 over the full jump, half that jump would be up by 3 and then up by 3 again. Up by 3 from 7 would give me 10, and up by 3 from 10 would give me 13. So I do know that worked out. So in terms of my start with and add each time, I know that my change here is going to be up by 3 every time x goes up by 1. Now for my start with, I again need to figure out what x's 0 matches to. And in order to do that, I'm going to need to go down by 1 from the current x value of 1, which means I'm going to have to go down by 3 over here, and that'll give me 4. Now you might notice that actually these two tables of values are the same. This one here is skip counting by 2, question D is skip counting by 1, but notice that both of them have a 0 and a 4. Both of them have up by 1 and x, matching up by 3 and y. Up by 1 and x matches up by 3 and y. Both of them have the points 1, 7, as well as 3, 13. And so these are actually the same table of values, which means the equations are the same. They're just disguised a little bit differently. Oops, I'm still on disappearing ink there. And I guess I should use my pretty colors. Okay, so let's check the other points that we didn't check previously. So we'll check 1, 7 in this one, and we'll also check the 5, 19. Obviously 1, 7 being this first point, and my 5, 19 being the last point. And I guess I forgot my color coding up here again, so 2 and 10, and 3 and 13. So we think the equation is y equals 3x plus 4. This point tells me that a y value of 7 should be made by 3 times an x value of 1, and then adding 4. So is 7 equal to 3 plus 4? Yes, it is. For my next point, again, I'm checking my equation, 3x plus 4. This point should tell me that a y value of 19 should be equal to 3 times an x value of 5 plus 4. 19 is, in fact, equal to 15 plus 4, so I do know that that point worked in my equation as well. And I guess I'll recolor code this one as well. Okay, finishing up, we have, again, a different change. So our change here is up by 2 when y is up by 4. And again, we're missing our 0 row. Now, where would 0 go? 0 would go halfway between -1 and +1. So to do that, I'd have to go up by 1, which is half of going up by 2. So if I'm doing half an x change, I'm going to do half a y change. That would put me at 11. And then going up by 2 again obviously does get me to 13. So I know that my pattern did work out there. So I'm going to be starting with 11 in this case from my 0 row that I just figured out. And we're going to be adding 2 each time. Remember, each time meaning each one change in x. So we're going to have y equals our coefficient of 2 each time, and then our plus 11, since we're starting with plus 11 or positive 11. Let's check any 2 random points. Now I will mention that since we don't necessarily know how to multiply by negatives, we should choose our positive points down here. So I'm going to check the point 1, 13. And I'll also check the point 5, 21, although again, it doesn't matter which 2 points you choose. So my equation says that y should be made by 2 times whatever x is, and then adding 11. This point tells me that a y value of 13 should be made by 2 times an x value of 1, and then adding 11. 13 is equal to 2 plus 11, so we know that the equation worked for that point. Likewise, we can go ahead and check our equation with the second point. The second point tells me a y value of 21 should be made by 2 times an x value of 5 and then adding 11. That tells me 21 should be equal to 10 plus 11. 21 is equal to 10 plus 11, so I know that my equation is correct. So notice it's the same procedure every time. We're looking for that 0 row to find our constant. So when we find that 0 row, we do get our constant. And we're looking for the changes to inform our coefficient. Remember, though, that your changes have to be for every one change in x. So if your x change is bigger than 1, you're going to need to divide to find that correct coefficient, so that you divide down to a change of 1 in x. So I hope that's helped you with forming the relation equation for a table of values.